you can check the recording. I will keep the recordings up for a few weeks, but eventually I will delete them. If nobody is looking at them, then there's no point in there taking up space. Okay, so let's erase this. Anybody have any questions? You can always ask me questions during class, prior to class, and certainly emailing me questions. Okay, so let's just review, talk about what we had learned on Thursday. We started talking about equations, what we call linear equations, equations of lines when we graph equations. And we talked about, if I give you the equation of line, how to go about drawing the line. We also talked about finding something called the slope of the line. Let's just do a couple of problems from the homework to remind us how to do these things. First of all, let's say I gave you, this was example number 7, where the equation we were given was 2y minus 5x equals negative 20. And we wanted to use the slope and y-intercept to graph the line. This is in what we call standard format. What we want to do is put the equation in what we call the slope-intercept form, the y equals mx plus b form of the line. And in order to do that, the first thing we have to do is isolate the y. We have to get the y by itself. So in order to do that, I'm going to add 5x to both sides. And that's going to give me 2y equals 5x minus 20. And then I'm going to divide everything by the 2. So in slope-intercept form, this equation becomes y equals 5 halves x minus 20 divided by 2 is 10. And then we see that the slope, which we call the m, is 5 over 2. The slope is the number in front of the x, the coefficient of the x. If I asked you, what is the slope of this line? Now you can see it, it's 5 halves. And the b, which is what we call the y-intercept, is the number that has no x attached to it, is negative 10. So let's see how we can use this information to graph the line. So here's my piece of graph paper. Okay. Whenever I use the slope-intercept to graph a line, my start when I want to graph it is the y-intercept. We said our y-intercept is negative 10. That means I have to go down 10 on the y-axis to get my first point. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's my negative 10. So I start at negative 10 as my first point. So when you have the equation of the line, start at your y-intercept negative 10. You then use your slope. Remember, we said our slope is 5 halves. The slope is what we call rise over run. So that means from this first point, notice I'm not starting at the origin, I'm always starting at the y-intercept. I have to rise 5, run 2. So that means count 5 up, 1, 2, 3, 4, 5, 2 over. That gives you a second point on the line. You want a third point? You can start now from this new point and again go up 1, 2, 3, 4, 5 over 2. 1, 2. And notice how these points line up. Here's my line. This is the line that you get from the equation 2y minus 5x equals negative 20, which we put in slope-intercept form as y equals 5/2 x minus 10. Again, the slope turned out to be 5/2 and the y-intercept was negative 20. Is there any question about this? Okay, so let's look at another question that we have for homework. This is question number 3. It says find the slope of the line passing through the points 1, negative 1, and negative 1, 1. I'm muted all. If you want to ask me a question, just unmute yourself. But there was outside interference. Okay, what do I do if I give you 2 points and I ask you for the slope? We saw in the other equation example, I gave you the equation of the y, and if I put it in what we call the y equals mx plus b format, then we see the number, the coefficient of the x, the number that's in front of the x is the slope. But what do we do when I don't have the equation of the line, I just have 2 points in the line? Then if you remember, we have a formula for the slope that goes like this. M equals y2 minus y1 over x2 minus x1. And I arbitrarily pick 1 point to be my first point, and the other point then becomes my second point. It doesn't matter which you call the first point, but if I'm calling this my first point, then this is what we call x1, and this is y1. x1 means the x of the first point. y1 means the y of the second point. These are subscripts, they're not exponents. Obviously, then this becomes my x2, y2. And if I put it into the equation, it's y2, which is 1, minus y1, which is negative 1, over x2, which is negative 1, minus x1, which is plain 1. Now I have here 2 minuses, and 2 minuses become a plus. So that this becomes 1 plus 1, which is 2. And this is negative 1 minus 1, which is negative 2. And if I divide 2 by negative 2, my answer becomes negative 1. My slope of this line is negative 1, because a positive divided by a negative is negative, and 2 divided by 2 is 1. Again, you could have just left it negative 1 over 1 if you want to write it as a fraction, rise over run. But actually, usually when we just write what is the slope, we just write, if it's a whole number, we just write it without its denominator. So we've seen 2 ways to find the slope of a line. One way is if we're given points, we use the point formula, y2 minus y1 over x2 minus x1. And if we're given the equation of the line, then we just put the line in the slope-intercept format and look at the number in front of the x. Now let's see, that was where we left off on Thursday. Let's see what we can use this slope for. What is the slope telling us? So obviously it's telling us the slant of the line, the rise over the run. That we saw. It definitely was helpful if we wanted to use it to graph the line. But there's other things that we can tell from the slope. If you look at this picture that I'm drawing right here, here's one line, here's another line. If you notice, these two lines are slanted exactly the same amount. These two lines are what we call parallel lines. You know what parallel lines is. No matter how long you would extend these lines, going up or going down, those lines are never going to meet. They're always going to be the exact same amount apart. They are parallel lines. It turns out the parallel lines are slanted exactly the same amount. In other words, if we talk about the slope of these two lines, the slope of parallel lines are equal. So if I were to tell you, for example, that the slope of this line is 3/2, and I would tell you that this line is parallel to this line, then the slope of this line would also have to be 3/2. Sometimes they're not reduced fractions, but if they're both in the same reduced fraction format, then they're both going to be exactly the same thing. Two parallel lines have the same slope. Again, parallel lines have equal slopes. We're going to see that even if I wanted to test to see if two lines are parallel, I would be able to by looking at the slopes of the line. I don't have to graph them. I don't have to look at the picture. I just have to look at their slopes. If their slopes are the same number, they have to be parallel. There's something else we can tell from slopes. Sometimes I have lines that look like this. Here's my graph. And I have one line that goes this way and one line that goes this way. It's crossing it. These are not parallel lines. They are intersecting lines, but they're intersecting. They're meeting in a particular method, in a particular way. The angle that they're meeting at are what we call right angle or 90-degree angles. You're getting these square corners where they meet. These type of lines are called perpendicular lines. Two lines that meet at right angle are perpendicular. Now I think it made sense when I told you when two lines are parallel, they're going to have the same slope because they're slanted the same amount. And slope tells you how they're slanted. It turns out that you can tell when lines are perpendicular from their slopes also, except it's not quite so obvious. You're just going to have to sort of take my word for it. If you have, it can be proven, what I'm saying can be proven, but you need higher mathematical skills than you have at this point. So I'm just going to give you the fact. Perpendicular lines have slopes that are what we call opposite or negative, either term. Opposite reciprocal slopes. What does that mean? Let's say I told you the slope of this line was 3/2. then the slope of this line would have to be the opposite reciprocal of that, which means flip it over and change its sign. It would be -2/3. The opposite, or negative, means it's the opposite sign. The reciprocal means it's flipped over. Here are some other examples. If I tell you the slope of one line is -2, then the perpendicular line, which is really -2/1, the perpendicular line slope would have to be +1/2. It's the opposite in sign, it's the fraction flipped over. Again, if it's a whole number, you put it over 1 and you flip it over. So you can tell if two lines are perpendicular, again, by looking at their slopes. They're not going to be the same number, they're going to be what we call opposite reciprocal slopes. So these are two important facts that you can tell just from slopes. Let me give you an example. Okay. Here are two lines. One line is a line 5x minus 2y equals 8. That's line number 1. And line number 2, equation is 2x plus 5y equals 10. Different line altogether. Both of these lines are in what we call standard format. I'm going to give you a couple of minutes while I take attendance. I'm going to ask you to find the slope of each line. That's going to be question number 1. And question number 2 is looking at the slopes. Once you know them, are the lines parallel, perpendicular, or neither? Either. Okay, I'm going to take attendance while you're looking at this problem. Yesenia. Yesenia, you here? The slope of the first line turned out to be 5/2. The slope of the second line turned out to be -2/5. That's by putting them both in the y equals mx plus b form. And when I compare the two slopes, I see that the slope of the second one is the opposite reciprocal to the slope of the first one. It's the fraction flipped over, and it's the opposite sign. And as I'm trying to think who actually told me this, Wendy told everybody, yes, these lines are perpendicular because their slopes are opposite reciprocals. Is there any question about how to do something of this nature? Okay, so let's go on to the next step. We are now at the point where we can take a description of a line, either telling some points on the line or telling something about the line, and from that description, we should be able to write the equation of the line. Now, Bernardo, you asked me if both lines are perpendicular. lines are perpendicular to each other. You can't have one line being perpendicular. It's how two lines are meeting. So to say the lines are perpendicular is telling you the relationship between the two lines. Is that clear? Okay. Okay, good, great. Okay, so now we're going to take a description of a line that looks like this. It says, write the slope-intercept equation for a line with the given characteristics. We're told that the slope of the line, m equals, this is example number 8 on the sheet, by the way, m equals 2, and it passes through the point 1, negative 3. We're being given a description of a line by telling you what a point that's on the line. One of the points on the line is a point 1, negative 3, and also what the slope is. If I wanted to, I could have drawn this line because I have a very good description. But what I wasn't given is the equation of the line, and we'd like to write the equation of the line. So how do I write the equation of the line? In general, to write the equation of the line, I'm going to do y equals mx plus b. I'm going to figure out the m and the b, and then I'll know the equation of the line. That's the slope-intercept format of the line. The first thing we always work on when we're looking to write the equation of the line is the slope part. What is the m? Well, we were lucky. They told me what the slope is. They told me the slope of this line is 2. So the equation of this line is going to be y equals 2x plus some b. I don't know what the b is. The b is not negative 3. Negative 3 is not the y-intercept. This point is just giving us any old point. Since the x is not equal to 0, the y-intercept is not negative 3. How are we going to figure out what the y-intercept is? Well, here's what we're going to do. We're going to, since this is a point on the line, when I stick in the x, replace the x with 1, and the y with negative 3, that is going to make a true statement. In other words, I'm going to replace, this is going to be my 1, and this is going to be my negative 3. So let's see how that works. I'm replacing y with negative 3, so this is going to give me negative 3. This is a 2 times the 1 because the x value is 1. So 2 times 1 is 2 plus b. Notice I'm left with a really simple equation that I can solve for b. All I have to do is bring this 2 to the other side. I'll subtract 2 from both sides. And this will give me negative 5 equals b. So substituting in the coordinates of the points into the equation allows me to solve for b, and now I know that the equation of this line has to be y equals 2x minus 5. The slope is 2, and the y-intercept is negative 5. So that's how we write the equation by taking the description. Notice we first filled in the slope, and then we used a point to figure out the y-intercept. Okay, let's do another type of equation like this, another problem similar to this. Not exactly, but similar. Okay, any question before I go on? Let's look at question. If you have your sheet, your example sheet, let's look at example number 11. Number 11 looks like this. Write a slope-intercept equation for a line with a given characteristics. It passes through the point 5, -6, and 2, -4. I am giving you 2 points on a line. You could certainly graph it. All you'd have to do is plot both of those points and then connect them, and you'd have the line. What, again, I haven't given you is the equation of the line. How can I write the equation of this line? So, again, we're going to write the equation in the y equals mx plus b form. And again, the first thing we want to fill in is the m, the slope. In the previous example, we were actually told what the slope of the line is. Here we haven't been told what the slope is, but we do have 2 points. And we know when we have 2 points, we can figure out the slope using the slope formula y2 minus y1 over x2 minus x1. Again, the first thing I'm going to do is figure out what the slope of this line is. Let's call this our x1, y1, again arbitrarily, and this our x2, y2. And sticking that into the formula, it'll be -4 minus -6 over 2 minus 5. And remember, again, a negative and a negative become a positive. So this is -4 plus 6, which is +2 over 2 minus 5, which is -3. The slope of the line then must be, now I don't really like the negative on the bottom. It doesn't matter. When you have a negative in a fraction, it could be in the denominator. You could move it to the numerator, or you could move it right in front of the equation of the fraction. The slope of the line, we now know, is -2/3. I'm halfway there. I know my equation is going to be y equals m, which is -2/3 x plus b. I still have to find out what the b is. What is the y-intercept? And I'm going to do that by, again, taking one of the points, it doesn't matter which one, and replacing that into the equation so that I can figure out what the b is. These numbers look a little smaller, so I'm going to work with these numbers. It doesn't really make a difference. In other words, I'm going to replace the y with -4, and the x I'm going to replace with 2. Okay, now I'm going to put this everything over ones, the whole numbers, because I've got fractions that I'm working with also. I have to be careful with the fractions. So this gives me -4 over 1. Remember, when I'm multiplying fractions, I first see if I could cancel anything, and I can't. So I just multiply the numerators. -2 times 2 is -4 over 3 times 1, which is 3, plus b over 1. And then one of the methods we learned when we're dealing with fractions and equations is to multiply by the common denominator. Now, the common denominator is 1 times 3 times 1, which is just 3. So I'm going to multiply everything by 3 over 1. Okay. So over here, I'm going to do, I think I still have room, 3 over 1 times negative 4 over 1 equals 3 over 1 times negative 4 over 3 plus 3 over 1 times b over 1. I have distributed it this 3 over 1. Okay, so I'm going to have to erase some of this so it has some more room. So remember, we found out that our slope is negative 2/3. Okay, so I am erasing from here on. And I'm working over here. 3 over 1 times negative 4 over 1 is negative 12 over 1, which is negative 12, equals now 3 over 1 times negative 4 over 3. The 3's cancel, and this leaves me a 1, so it's 1 times negative 4, which is negative 4 over 1, which is just negative 4. And then it's 3 over 1 times b over 1, so that's just plain 3b. And I'm then going to bring the 4 to the other side. So I have negative 12 plus 4, which is negative 8, equals 3b. And to find out what b is, I have to divide by 3. And it turns out that my b is negative 8/3. And now I can write the equation of my line. Y equals m, which is negative 2/3, x plus b, so that's minus 8/3. And here is my equation of my line. From the description of the 2 points that were on the line, we were able to write the equation of the line. Remember, what we first did is we used our slope formula to find the slope of the line, and then we substituted into the y equals mx plus b one of the points. It could have been either point. You would get the exact same answer no matter which point you used. Does anybody have any questions? Okay. So then let's go on further. Let's try another type of problem. Let's say it had a problem that's like this. I want to write the equation of a line that goes through the point -2, -1, and is parallel to the line 5x minus 15y equals 12. Okay, I'm going to work this one out, and then I'm going to give you a few to try on your own. Okay. Let's understand what they're saying. They're giving me the equation of a line. Let's call this line 1. We know what the equation of this line is. They want me to write the equation of a new line, having the being that it's going to be parallel to this line, but it's going to be going through this point here. Well, we have to remember what it means that lines are parallel. What does that mean in terms of slope? What it means in terms of slope is that the two lines are going to have the exact same slope. I'll do this one very thoroughly, and then I'll do one similar to that again, okay? Is that okay, Dominic? Okay. Let's look at this one, because I think if you'll understand this one, it'll help you understand the previous one as well. I'll go through this really slowly. Again, we want to find the equation of a new line. Let's call it line 2, which is going to be y equals mx plus b. That's the equation of a line. What do we know about line 2? It's going to be parallel to line 1, and it's going to go through the point -2, -1. Well, if you recall, what we said about parallel lines is they have to have the exact same slope. So if I could find out what the slope of line 1 is, that would give me the slope of line 2 as well. The lines are parallel. They're going to have the same slope. So let's take this line 1 and find out its slope. Well, we knew how to find the slope of a line. We put it in the y equals mx plus b form. Notice it's a different y equals mx plus b than this one. It's the original line. We're going to solve for y in the original line. So the first thing I'm going to do is I'm going to subtract 5x from both sides, which will give me -15y equals -5x plus 12. And then I'll divide everything by -15 to get the y alone. So in simplest form, this will be y equals, well, here the -5 into the -15 will give us 1/3x. The -5 over the -15 reduces to 1/3. So this is 1/3 x, and we could reduce this also by dividing both by 3 plus, well, actually it's a minus because there's a minus over here, minus 4/5. Dividing this and this both by 3. Now I don't really care about this number because this is a y-intercept of the original. What I need is the slope. The slope of the original line is 1/3. When I put the line number 1 in y equals mx plus b form and I reduce, I got a number 1/3 as the slope of the line. The number in front of the x, if you got an x over 3, it's the slope is 1/3. The x is not part of the slope. The slope is 1/3. That means that my new line, the line that I want to write the equation of, its slope has to be 1/3. In other words, its equation is going to be y equals 1/3 x plus b. It's not going to, the b is not going to be -4/5 because that was the b of the original line. We want, all we needed to get from all of this is the number in front of the x, because that is the slope. Does anybody have any question as to how I found the slope of the line? Okay. So now we know the slope of the line. I'm going to erase this part so I can go on to the second part. We figured out my original line had a slope of 1/3. So my new line, which is parallel to the original line, also has a slope 1/3, 1/3. Okay, so here we are. Y equals 1/3 x plus b. We still have to figure out the b. And we always have to do this. This is how we always work a problem where we're trying to find the b. We take the point. If there's only one, in this case, they only gave us 1 point. In the previous example, we actually had 2 points. Any point that's on the line has to, the coordinates, the numbers have to fit into the equation of the line. So here, I can replace the x with -2 and the y with -1, because the point -2, -1 is on the line. So that'll give me, in place of y, I'm putting -1 equals 1/3 times -2 plus b. Now I'm going to put all the whole numbers over 1 because it's easier to work this way. So this is -1 over 1 equals, well, when I multiply these two fractions, 1 times -2 is -2. 3 times 1 is 3 plus b over 1. Again, my common denominator, there's a 1, a 3, and a 3. Multiply them all together. My common denominator is 3. We put 3 over 1 and multiply the whole equation by the common denominator of 3. Okay, so I'm going to distribute the 3. It's going to be 3 over 1 times -1 over 1 equals 3 over 1 times -2 over 3 plus 3 over 1 times b over 1. Okay, over here nothing cancels out, everything is 1, so it's just 3 times -1. That gives me -3 over 1, which is just plain 3. Over here, the 3's cancel out. And I have 1 times -2, so that equals -2 over 1, which is just -2. And over here, everything is, that's just 3 times b, so that gives me 3b. Okay, now to figure out what b is, I first bring the 2 to the other side. I'll try not to go, let's see, it's a little forward. And I have -3 plus 2 is -1. This cancels out, equals 3b. So it turns out that my b is -1/3. And therefore, I can now write my equation. My equation is y equals mx, so my m is 1/3, 1/3 x, plus b, so it's -1/3. And this would be the equation of the line in y equals mx plus b form that is parallel to this line and going through this point. So by describing the line and saying what saying the lines were parallel was equivalent to telling me what the slope of the new line is, and from the slope and a point, I can write the equation of the line. Any questions about this? Okay, I want to try one more, and then I'm going to give you some to try on your own. Can I erase this now? Anybody not ready for me to erase this? Determine the equation of the line described. Through -7, 0, and perpendicular to 7x plus 9y equals 18. Okay, great. Okay, we're going to do this, and then I'm going to ask you to ask me any questions. Again, I'm giving you the description of a line, and from that description, I want to write the equation of the line. Again, you want to write the y equals mx plus b of this line. They're starting with one line. Let's call this line 1. We're going to be writing the equation for line 2. What is line 2 going to be? It's going to be a line that goes through the point -7, 0, and it's also going to be perpendicular to the line 7x plus 9y equals 18. It's going to be perpendicular to line 1. Now, let's remember what it means when two lines are perpendicular. When the two lines are perpendicular, their slopes are opposite reciprocals. So telling me information about perpendicular lines is really giving me information about the fact that of their slopes. It's giving me information as to how to find the slope. And remember, when I want to write the equation of the line, I want to first work on what its slope will be. Well, what I'm going to do is I'm going to take this equation of line 1 and put that in the y equals mx plus b form so I can find out the equation, the slope of the first line. Using the slope of the first line, it'll enable me to find the slope of my second line, the line that I want to write the equation of. So putting this in the y equals mx plus b form, I'm first going to subtract some and x from both sides, which will give me 9y equals -7x plus 18. And then I'm going to divide by 9. So that this gives me y equals, well, -7 over 9 x. The coefficient of the x is -7, 9. And 18 divided by 9 is 2. And what I'm interested in is the slope of the line. The slope of line 1. This is line 1. The slope of line 1 is -7 over 9 because that's the number that's in front of the x. So the slope of line 2, well, the two lines are going to be perpendicular. And when we know lines are perpendicular, their slopes are flipped over and opposite signs, opposite reciprocals. I flip this over, so I get 9 over 7. And since this one is minus, this one has to be positive. They're opposite signs. This is what means their lines are perpendicular. So getting the slope of the original line gave me the slope of my new line. It wasn't the same number, it was the opposite reciprocal. So in my second line, in line number 2, the line I want to write the equation of, I now know what its slope is. Its slope is 9 over 7. So the equation of this new line that I'm trying to find the equation of is y equals 9/7 x plus b. I still have to figure out the B. The B is not 2. That was the original line. This is a new line. And the way I'm going to find out what that line's intercept is by replacing the x in the equation by -7 and the y in the equation by 0. So this will give me 0 equals 9/7 times, now this is -7, which I'll write as over 1, plus b. Now, this one worked out to be nice because the 7 over here will cancel into the 7 over here and leave us -1. So this will give me 0 equals 9 times -1, which is -9, plus b. And if I bring the b to the 9 to the other side, this will give me 9 equals b. In this case, it wasn't a fraction, it was a whole number. The y-intercept of this new line is 9. So my new line's equation becomes y equals, here's 9/7x, because the slope is 9/7, plus 9, because the y-intercept is 9. This is the equation that we were looking for. So again, from a description of the line, which enabled me to figure out what the slope of this line would be, and from a point, we were able to write the equation of the line. Does anybody have any questions about these? Okay, so now I'm going to give you some time to work in your breakout rooms. I know somebody sent me they want to be in certain breakout rooms, but you have to, if you're sending me a request to be in a certain breakout room, you have to give me your name and the other people's first and last names. I don't have enough of information to do it. So we're still going to do it by doing it, let the computer do the breakout rooms. What I want you to do is, I'm going to break this up into 5 breakout rooms. I'm going to give you 5 problems to work on. And I'm going to come to each breakout room and tell you which problem. You all have to do all 5 problems, but the problem that you're going to have to give the answer to. You can work as a group. These are the examples that I want you to do. Can I erase what's on the board? Everybody okay with that? This is on the practice example sheet 2. I want you to do examples 9, 10, 14, 17, and 19. Okay, I'm going to break you up into breakout rooms now. Let me just, I'll talk about homework in a minute. There are only 23. A lot of people have left, I see. Let's do 5 rooms. Okay. I'm opening the rooms now. I want you to join your breakout